All right, this is the scale drawings review for the final exam. I know this was a very tough topic for a lot of you, so I'm going to try to break it down. We're going to do this in 3 different sections. So let's start off with just defining what is a scale drawing. So a scale drawing or a scale model, they are used to represent objects that are too big or too small to be drawn to actual size. So a lot of those are like blueprints, maps, just like sculpture that's representing something that would be too big. So things like that. Now, first thing that we're going to talk about is something called a scale. Often they use a scale to tell us what the drawing dimensions are equal to the actual dimensions. So it says on a blueprint, the length of the wall is 5 inches. The actual length is 85 feet. So what is the scale? So what we have here is we have 5 inches in the drawing is equal to 85 feet. Now, when you write a scale, you usually start with the number 1. So to get number 1, we're going to divide both sides by 5 because 5 divided by 5 is 1. So 1 inch is equal to, now do 85 divided by 5. So 85 divided by 5 gives us 17. So 1 inch in the drawing is 17 feet in real life. This is what we call the scale. Okay, it's going to be what represents what inches in, or what units in the drawing represents what units in real life or the actual picture. So that's called a scale. Just remember it usually starts with a 1. All right, now let's talk about this thing called scale factor. This is the ratio of any 2 corresponding lengths. So to find it, we do the drawing divided by the actual. Now, this is really the constant of proportionality where you're dividing y by x. That's really what you're doing. I like to use drawing over actual instead just because it's a little bit easier to remember that the drawing goes on top. That's your y value. Your actual goes on the bottom. So let's go through 2 examples. The height of the building is 15 inches. The actual height is 165. So find the scale factor of the drawing. Now, one thing we should probably insert in here, this is 165. Let's make that, it wouldn't be inches, so let's make that feet. Okay, so scale drawing means we're taking y and we're dividing x. And if you want to write that that's the drawing over the actual, that will just remind you that the drawing number goes on top, the actual number goes on the bottom. So in the drawing, the height of the building is 15 inches. Make sure you use the inches because you're going to need those to be the same units. So you want to make sure that they're labeled. The actual building is 165 feet. Now, the only thing is you have to make sure when you're doing this that these are the same units. They are not right now. So we're going to leave the inches and we're going to change 165 feet to inches by multiplying by 12. So 165 feet is actually 1,980 inches. So all I did was multiply that by 12 to give me those inches. Now the inches cancel out. Let's see if this reduces. I'm going to type in 15, ABC 1980. And when I do that, I get 1 over 132. So my K value is 1 over 132. That's my answer right there. So my K value is 1 over 132. Now that makes sense because the scale drawing is smaller than the actual building. So it's 1 and 1/32 of the actual building. All right, I know that's confusing. So we're going to try another example just like it. It says using a photocopy, you want to reduce this poster to a smaller size. What percent reduction should you use to find? So we're going to find the scale factor and write it as a percent basically. So scale factor we're going to do is y divided by x. I would write that you're doing the drawing over the actual. So this is the actual poster right here because we're going to reduce it. And this would be your drawing. All right, so take one of the dimensions. Say we take the top length. That would be 6 inches. The top length of the actual is 30 inches. Now, they're already both in inches, so we don't have to change the units. So inches cancel out. Now, we're going to reduce 6 over 30. So 6, ABC 30 is 1/5. So that's my K value, but we want to know, that's our scale factor, but we want to know it as a percent. So I'm going to do 1 divided by 5 is 0.2. And 0.2 is the same thing as 20%. So that's called a scale factor. Now, let's go to the missing measurements. This is really what I see asked on state test final exams. So when you're finding missing measurements, we're going to set up a label. We're going to write and solve a proportion using the scale. So let's read. It says, here is the scale. We know the length of Lockport Road. We want to find the actual length. So if you look in the scale, we have 2 units here. We have inches and miles. So I'm going to set up my label as inches over miles. So I know from the scale that 1 inch is equal to 25 miles. So my first fraction is 1 over 25. I know that the length of Lockport Road on the map is 2.4 inches. Inches are on top, so I'm going to put 2.4 on top. And I want to know the actual mileage, so that would be my x. So I'm going to cross multiply. 1 times x is 1x. 25 times 2.4, I'm going to bring in my calculator. 25 times 2.4 is 60. Divide by 1, so x is equal to 60. So that would be x is 60 miles. That's the length of Lockport Road. All right, let's try that again. Number 2. Marta made a scale drawing of the elementary school. The scale is 1 millimeter equals 9 meters. The actual is 72 meters. What is it in the drawing? So we have millimeters and meters. So I'm going to make a label, millimeters over meters. I know that 1 millimeter is 9 meters, so that's my first fraction. The other number I'm given is 72 meters, so that goes on the bottom because meters are on the bottom, and I want to know how many millimeters that is. So I'm going to cross multiply. 9 times x is 9x. 72 times 1 is 72. Divide both sides by 9, so x is equal to 72 divided by 9 is 8. That would be 8 millimeters. So it's so much easier just to have a proportion when you're finding missing sides. Now, like I said, these are the majority of the questions that you'll see on the state assessment or the final exam. So those are what we're going to be practicing in class. You can try the problem set for homework tonight, and we will go over that in class tomorrow. Good luck.